Hello, Prof. Amal.
Good morning. Good morning, Mr. Amit Jain. How
Yes,
are you? How are you?
I'm good. I'm good. Juggling with between three meetings.
You are incredible, I should say. How do you manage it?
I
How
don't
do you
know.
manage it? Oh my
After
God.
after after we set your date, suddenly a few other things come. One is the briefing for the national grant application. They are giving a briefing to the reviewers. So they gave a very short notice.
That's a
Unfortunately, I couldn't cancel both.
that's a big thing. That's a
Yeah.
big thing that you have a lot of responsibilities there.
Yeah, they are coming out with the new guidelines, so we need to be updated.
So you'll tell me the new guidelines so I can be updated myself, doing
Yes,
research with you also. Yeah.
yeah, yeah. I think they are thinking this national grant are mostly thinking of pre-marketing strategies. Something like when you do a research, they want to have a marketing plan in mind. But I'm a bit reluctant because not all research produces products. So I don't know. That's why I need
That,
to see.
Yeah, that's one thing I learned 2 years ago going to a conference. The marketing. How do you sell your product? I mean,
Yeah,
we are not businessmen. We are scientists. So that's
yeah.
interesting. That's a really
Yeah,
interesting model. Yeah.
yeah,
Mhm.
but well, if you're doing something on basic science, it's nothing to be marketed. But I don't know. I think now researchers need to think in the business way rather than a pure scientist way.
Right. Right. That's true. We can discuss that. That's the important thing, but interesting.
The entrepreneurship.
Yeah. 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 I mean, there are a group of
Hmm.
people, they actually go to scientists and get your product and try to sell in the market and make
Yeah,
money.
true,
So
true.
that's the bottom line. So
Okay, I think we have quite good number of participants this morning. We have 61.
oh,
We have
really?
61
that's
people.
that's
I
so
think
good.
this is, I think they some will join in
Uh-huh.
to listen to you, but I have to excuse myself and rejoin the meeting, and I will definitely watch your recording on our PPSK YouTube channel, and yeah, inshallah I'll try to come back again before you finish.
And please send me all those things, recording and PowerPoint. I will change little bit. I will send you the updated one.
Okay, great, great.
Yeah.
I wish you a good session and
Thank you.
productive session with the participants. Thank you very much, Prof. Amal. Catch up
Thank you
later.
so much for organizing everything. So
Okay, bye.
everybody, good morning. Thank you. Thank you. Let me begin saying hello to everybody, and this would be, I think, very important session. I just want to know from you, if you do research, what most important thing that you need to know in doing a research? Just tell me either in chat or you can unmute and tell me what you think. The most important thing that you need to know in conducting a research. Please respond as soon as you can. Just one thing, tell me. One thing that you need to know for sure in doing a research. Correct sample size, that's very important. Yes, that's so important, Fatma. I know, I'm sure. Okay, is the audio working? No, I don't hear. Um, so you said valid source sample, the objective of the study, valid source, enough sample size. Yeah, so I think it's Miss Elisa said objective of the study. Definitely, these are all important. Rationale of study, all these things are important. Yes. Definitely, I would say one very important thing, we start with some objectives, and we definitely need the methodology. All the steps are important. Correct way of data collection, all the tools to data collection, all these things are important. But before doing a study, you must calculate your sample size. And there are many formula because we have many types of research. Is there anybody who have done research before? Just tell me yes, some people. Tell me yes, who have done research or involved in any research before. I can see a face, please speak out. Or you can say, oh, you cannot, you said you cannot hear me? Anybody has problem hearing me? If you do not hear, it may be something in your end, because we talked with Professor Hamid Jan, he said, fine, I heard him well, and sound is clear. Okay, good, sound is clear. So anybody did research or involved in research? I did cross-sectional study. Is Sidra Mohiuddin? That's how you spell your name, Sidra Mohiuddin? Yes, okay, so thank you. And you gave me some information about Pakistan. Are you from Pakistan, or you have information about Pakistan, about COVID-19 situation in Pakistan? I saw in the chat. Okay, you are from Pakistan. Okay, good. I went to Karachi back in 1980s, sometime, early 1980s. 92 probably, or 84, I forgot. So another person said, yes, I did cross-sectional and longitudinal studies. Good. So you have done longitudinal, means you have done most likely a cohort study, I believe, but longitudinal can be many other types also. Okay, so knowing your background, you already know some of the things about doing sample size. But I will start with very basic things today about cross-sectional study sample size. So only one type of study sample size I'll be talking about, that is cross-sectional study. And again, cross-sectional study usually we do with one sample. Like if I do, say, let's say breastfeeding study, okay? So I go to the community and ask about their breastfeeding information and some other variables such as demographics and other things. So that's a one sample cross-sectional study. But cross-sectional study can be more than one sample also. Like in Mississippi, we have 82 counties, 82 places. I can do a breastfeeding study in, let's say, in urban area. I can do it in rural areas, okay? Then we have two groups of samples, but it's a cross-sectional study. Then we can do comparison of the cross-sectional data between the two groups. If you have that situation, then you have to multiply your sample size by 2. If you have two groups, you have more than two groups, multiply with the number of groups that you have. But normally, it generally is one group. So the thing that I'll calculate today, show you the calculation, is for one sample, but if you have multiple samples, you'll multiply with that number. Is that okay with you? just show your thumbs up. Okay.
Okay.
Okay. Now, good. So this is, and then I'm sharing my, okay. Okay. This is my, okay. Let me minimize my, get something out of my way. Okay. Let me see if you need it to make it larger or not. Let me see how I do that. Increase that. Okay. I don't know. You can see that in one. I think this should be okay. Can you see it in one frame? Do you see it? Yes. Okay. So this is our sample size information here about cross-sectional studies. Okay. Okay. So certain things we need to know. Okay. What are the things we need to know? There is something blocking my way. I trying to take it out from my, okay. Okay, so we need to know some baseline data, some baseline data. Is this slides clear to you? Please say yes or no. Somebody. Is this okay? You can see them? Is it better now? Okay. I don't hear you, but or I cannot see your chat. Okay, let me see your chat. Yes, sir. Okay, thank you. Thank you so much. Okay. All right. So yes, thank you. So we need some baseline data. Like I said, if I want to do a cross-sectional study on breastfeeding, I'll need to know what is the baseline data for breastfeeding. And we know breastfeeding can be at birth of the child, it can be at 6 months, it can be at 1 year, it can be 12, 2 years or so. So we have to have some timeline that you want to study. So we have to have some baseline data about the variable of interest or about the study that you are trying to do. So how do you get the data? Normally is published literature. And how do you get them? From the literature, you try to find out previous study in the population that you are working. Sometime you may not get data from your own population in Malaysia, then try to get information from neighboring countries, similar culture, similar things. So you try to get some data about the similar population that you are dealing with. Now, if you do not have previous studies, sometimes it happens. Like I did one study when I was in Kuwait. I didn't have data for Kuwait. I tried to get data from neighboring countries, Saudi Arabia. So that is okay. But if you do not have any published literature or on some topic that you are going to study, because it's a new study, nobody did it before, you can do a pilot study. You can do a short, small study. We call it pilot study, and get the data before you go for a larger study. Pilot study data are sometimes very important for your population. So if you want to do a large study, think about some small study before you go for a large study. Now, if you cannot do a pilot study, and if you do not have enough published data, what do you do? Can you still do sample size? Can you still do a research? Yes, you can. And how? Yeah. So you can do some professional guess. Why? How? I'll ask my colleagues. I'll ask my friends who has done similar studies, or suppose they are working in a hospital or in a community. They know what is the roughly rate. We call it prevalence rate. By the way, prevalence and incidence, two important things. In cross-sectional study, you can only do prevalence. You cannot calculate incidence in a in a cross-sectional study. Prevalence means existing cases. How many people are breastfeeding? Some women may be newly started breastfeeding. Some people maybe already had experience before, or they are doing it for a long time. So it can be all cases plus new cases. Together is called prevalence. And what is incidence? Only new cases. Only new cases is incidence. If you do a cross-sectional study, you can only do prevalence, not incidence. Please remember this. I had a situation, I was on the IRB, Institutional Review Board. My previous position at USM, that's called University of Southern Mississippi. Somebody wanted to do breastfeeding study, breast cancer study. And she proposed a cross-sectional study, but she mentioned is incidence. She wanted to study incidence in her study. Because she didn't have background in epidemiology or public health, she didn't know the difference between incidence and prevalence, although she is a good scientist. So this basic information, very important. Okay, so to do a cross-sectional study, you can only calculate prevalence, not incidence. So the data that I'll give you or will get from published data is about the prevalence. It's about the prevalence. Okay, that's number one step. Okay, then what? You have to set up some numbers. You, as a researcher, will decide before you do the study, you'll decide what is your alpha value, what is your beta value, what is your confidence, what is your power. Okay, let me explain these things. Okay, alpha is the probability of type 1 error. I cannot go further about it because it will take a long time. So in short, alpha is the probability of doing type 1 error. Beta is the probability of doing type 2 error. 1 minus alpha. 1 minus alpha is confidence. And 1 minus confidence is alpha. So if you have alpha, you can calculate confidence. If you have confidence, you can calculate alpha. 1 minus confidence is alpha, and vice versa. Same thing with beta. 1 minus beta is power. 1 minus power is beta. Okay? Please remember this thing, because sometimes you will be told, as a statistician, you will be given this problem. I want to do a study with 95% confidence, 80% power. What would be my sample size? Or they can say, you calculate your sample size, but you tell me what is the power of the study. So you have to know what is the power, how to calculate it. Okay. Other things. So you set up what would be the power of your study. You set up how much confidence would be in your study. You set up alpha and beta. What else? To begin with, you need to know what is the effect size. What is effect size? We use a notation D for difference. Effect size means how much difference do you expect from the real value. So in the population, there is a real value. We don't know that. What is the real value? What is the real breastfeeding rate? We do not know because we didn't study everybody, okay? We can only study a sample. So how close you want to go to the real value? How close? Closer is better. That is called precision or effect size. So more precision, more precise means your effect size is small. How small is small? Normally, we calculate sample size with an effect size of 4% or 5%. 4% or 5%. If it is 10% effect size, okay, you are expecting 10% difference from the real value. That means you are going away 10% from the real value. Sometimes we have to do that based on our available resources, but you have to compromise. You have to come to a point that you are not using a large sample, large effect size. Has to be close to the real value. I'm seeing that somebody telling you do not hear me. Is everybody not hearing me? Or is it a problem that from my end or your end? I'm not sure. Again, you say, I'm okay. Okay, good. Please make your system so that you can hear me. They said clear hearing. Okay, all right, no problem. So, but please make sure your microphone is working, your computer is working. So this is effect size. You have to set your effect size. You as a researcher will do that. How close you want to go from the reality. Very close is good. Very close means sample size will be larger. Wider means your sample size would be smaller. But be realistic. What should be a good effect size? Okay. Other thing is, are you doing a one-tail test or two-tail test? What does it mean? A simple example I give you, I studied iron supplementation. It's a nutrition study. I did a lot of nutrition studies. Some nutrition supplements, iron. I did a study in Bangladesh, more than 500 children. I gave them iron supplements every day for 1 year. 1 year, quite a long time. And I studied their growth and morbidity. Morbidity means disease. Like, let's say growth means whether children are growing or not growing after giving iron supplements. It's a one-tail test because the outcome of the research is growth. Children will either grow or not grow, but their length will or height will not be shorter. Okay, so it is one tail. Outcome is one direction only. But I did same group, I did study on the same group for their morbidity, for their disease after giving iron. Do you know what happened? After giving iron supplements for 1 year, very small children, 6 months to 12 months of age, their one disease, their incidence, because it's a forward study, that went up, but others, that is shigellosis, blood dysentery, but all other went down. So outcome can go to any direction, good, good or bad. If that is the case, you do a two-tailed test. For example, COVID-19. If you tell this medicine I'm giving for Omicron, COVID-19, I'll see if it works or not. It's a two-tailed test because we do not know the outcome. Okay? Most of the time, please remember, we do two-tailed test. Only few exceptional cases we do one-tailed test. Because in reality, most of the time, we do not know what would be the outcome of our intervention, if there is any intervention. Okay. So this you will determine before you do the study. These things will set up before you do the study. So some cases, you have data which is in proportion or percentage. Percentage of people are breastfeeding, proportion of people out of that many people are breastfeeding. That's proportion or percentages. That's one type of data. There could be other type of data that you have mean and standard deviation. Mean and standard deviation. Then you have to do other type of analysis, other type of sample size. I'll talk about that in my next lecture on sample size. Please do not miss that next lecture also. Okay. Today I'll be dealing with only proportion. The other information you need to know. Once you get the sample, you determine how many people you need to study. In reality, this is very important, very important. So if you calculate, I need only 300 people, and you start your journey, you start your research, eventually you see that 25 people are dropping out. They are not staying in your study. So your study will not be perfect if you begin with 300 people and certain number of people are dropped out. So what you need to do? You need to begin with a larger sample. How large? If you decide I have 10% dropout, I anticipate that 10% people will be not staying in my research. Then you add 10% of the sample size, of the required sample size. You calculate 10%, add them to the total to begin with, so that if some people are dropped out, you are not in a problem. This part is very important. Then I said, whether you have one group, two groups, or more, depending on that, you'll multiply with the number of groups for the total sample size. Good. So these are the information you need to begin with sample size calculation. Now there are many formula. I'll be talking with only one type for the cross-sectional studies. There are many other type of study that we do, and sample size calculation are different for them. That's not our things to do today. We'll be doing only cross-sectional study. Good. So we need a formula, right? This is a formula. N is the number of sample size. Z is a notation that used for Z-test or Z-test, we call it. And that number is 1.96. That number is a fixed number depending on two things. One thing is what is your alpha, and other thing whether you are doing one tail or two tail test. I said most of the time we do two tail test. Therefore, for two tail test having alpha 0.05, my Z value would be 1.96. How do you know it? It comes from a statistical table. Any textbook, you'll find this number, but you can just memorize this number that you have to use 1.96 for Z value. Okay, so there is no T value here, is a Z value for this calculation. Then what is P? That's the most important thing that you get from the baseline. And that is the proportion that is known. You will use that number as baseline data to calculate the sample size. That baseline data comes from the literature or pilot study or your professional case. You have to have a number. So sometimes people ask me, I want a sample size for my study. I always tell them, give me this information. Give me information about the proportion of whatever you are studying, percentage. Give me that number. And give me how much precision you need. You tell me, or I select that for them. Usually I said 4 to 5%, and we do not expect a large difference from the actual value. Okay, so we're almost ready to calculate sample size. Okay, this is an exercise. This is a study that I did in Kuwait. We wanted to know the proportion of people who had the correct knowledge about organ donation. That study was published. My students did it. My master's students. Actually, this was actually with the people who were medical students. They did this study, and I'm the last author. So we published that. I can do it with you also. If you collect data, I can help you also publication. That's my aim also. So in this study, we didn't have data from Kuwait. So we collected data, got the data from the literature about correct knowledge about organ donation from one study done in Saudi Arabia. That was 10%. So 10% of the population had correct knowledge. Now you want to do with that data a study and calculate sample size. And your precision is 5%. So that's you set up that number. And dropout, you expect that 25% of the people, once they're enrolled in your study, may be lost. May be lost means they will not retain in the study. So what we'll do, we'll calculate sample size and add 20% of the required sample size. 20% of the sample size that you need, you'll add that to the total to begin with. So you'll begin with 20% more than what you need, so that if somebody drops out, you will not be in a problem. Okay, let's do it now. So I said this is the formula. Z is 1.96. We are doing a two-tail test, okay? And I said we got 10% for the prevalence of the people who had the correct knowledge about organ donation. I translate to decimal. So 10 divided by 100.1, that is your P. That is your P. How do you do it? 10% is the baseline data, divide by 100, that's 0.1. So what is Q? 1 minus P. 1 minus 0.1 is 0.9. Do you follow me? Do you follow me? Please tell me on the chat. Thank you. Thank you. Thank you so far. Thank you. So you have P 0.1, Q 0.9. What is your D? I said 5% precision. 5 divided by 100, 0.05. Please be careful. It's not 0.5, 0.05. So make it always important to calculate properly. Calculation error means everything error. Okay, so we have P, we have Q, we have D. We have P, Q, and D, and we have Z value. Everything we have here. Okay, so now we can calculate. Okay, and I said that we have 25% dropout, right? So I plug in the number 1.96 square times 0.1, that's P, 0.9 is Q, D is 0.05, square it, calculate, I get 138, and I want to get a whole number, 138. That is your required sample size. However, we said that 25% may be dropped out. So I will increase that number by 25%. Means 138 times 0.25. 138 times 0.25 gives me how much more I need. So 25% of 138 is 35. Please do that at home. Please do this exercise at home so that everything is clear to you. 25% of the required sample size. I need 138, but everybody is not staying in the study. 25% may drop out, We don't know really, but we have to set up a number. And that number comes from your previous experience or the same population, you or somebody else have done some studies, you get that number is an assumption that many people can be dropped out, may not be stay in the study. So you add that 25%, which is 35, to the total. 138 is the required sample size. Add 35 because they may be dropped out. Total is 173 that you need to study. Is that clear? Any questions so far? Good. Thank you. Please tell me if you are following or not following. So I have seen many people does mistake here in my class. My 24 years of teaching, I've seen many people subtract this from the total. No, you add them to the total because you need more people to begin with. You need 173 people to begin with, because 35 people may be dropped out, so that you you have 138 who you need for your study. If you have more, not a problem. But if you have less, there is a problem. Your efficiency, your power would be less if you use a smaller sample size than what you require. Okay, somebody asked me, let me see. Somebody asked me, if we do not put dropout, is it okay or not? It's not okay. So you must use a dropout rate, because any study you do, any perfect condition you have, you'll always have some dropout. Okay, so if you expect that you have 25, you calculated sample size with 25% dropout, but eventually your dropout, let's say 15%, okay, or 10%. So you are in good shape because you started with a larger sample size. You are in good shape. However, I did a study. I expected, let's say 20% or 25%. Okay. Somebody asked me, is 20% or 25% acceptable? That depends. That depends on what study you are doing, what type of study you are doing. Okay, let me explain this. If you do a study with a group of people who are kind of poor people or illiterate, literacy rate is low and poor, let's say you are doing as a sample among those who do not even have a cell phone, or they do not stay in same house because they are so poor that they cannot afford a housing. They move from one place to another. Okay, in that situation, you may have to do a larger sample size because the dropout may be larger. So what is the magic number? There is no magic number for dropout. You have to justify. You have to justify based on the area, based on the population that you are studying, based on the type of study that you are doing. Another example I give you. Let's say you are doing a face-to-face interview. Face-to-face interview. You are going door to door, you are collecting data from everybody. In that case, dropout rate would be very minimum. It may not be even 10%. Maybe 5% will refuse. No, we do not have time to participate in your study. We do not have time. So many people may be refusing based on their time. So let's say 10%. So you add 10%. You anticipate 10% will do that. But if you do a telephone survey, for example, okay, telephone survey means you really do not get everybody that you expect. Many people do not answer your telephone. Many people do not have a telephone. Now, many people have telephone. Okay, so that's not the case for now, but in the past we didn't have many people a cell phone or something, even a regular phone. So in that case, telephone survey will definitely have smaller, will have larger dropout. So you have to. So these are the things you have to account for when you plan for a study. What would be your dropout? There is no magic number. I was telling you about one study that I did. Iron supplementation in postpartum women. in low income population, okay? That's one thing you have to consider. And then we had Katrina, big tornado, okay? One area that our study area washed out. People had to move from the area to another place for permanent, you know. So I had a large dropout, and I had to really justify publication. If you have a large dropout, it's kind of problem because the population that you are studying may not be same that if you could do a larger is if the dropout is less, because we have to make sure who are dropped out, their characteristics, and those who are retained in your study, those who are in your study are similar. If the dropout population had a different demographic characteristic, then you are in problem. Okay, let's say older people are dropped out, younger people are retained in my study, then you are a problem because your study cannot address the whole population. Your study can address only younger population. So remember, when you make an inference about your study results, do not generalize it. Be fair about what population you studied. Okay, let me go forward because I have to tell you a I have to give you a few more examples. So this is another study. A hospital administrator in Mississippi wishes to know what proportion of patients admitted to a hospital for the treatment of trauma die in the hospital. Okay, so we need a baseline data. And the baseline data is that 20% of people who are admitted in the hospital, they die of trauma. Okay, so another question is, if you know that data, why you need another study? Okay, that's a good point. So we are doing this study because we need to go for another population to see what happens to that population based on this information. Okay, so 20% means 0.2 is your P, and then what we have 95% confidence means alpha is 0.05. 1 minus confidence is alpha, so 1 minus 0.95 is 0.05, that is your alpha. If it is too complicated, just ignore this thing, okay? What is the width of the interval? This is another term we use for precision, width of the interval. I use 4% in this case, so we'll go to 4% precision. 4% means good, is closer to the real value. You calculate the sample size. Okay, so P is 20%, 0.2. Q is 1 minus 0.2 is 0.8. Confidence 95 means 0.95. Alpha is 1 minus confidence is 0.05. We are doing two-tailed test. Therefore, G is 1.96. How do you know this? I told you G value depends on two things. One is what is your alpha value and what is whether you are doing two-tail or one-tail test. Okay. D is 4% means 0.04. Now, can you tell me some information is missing here? What is that important information that you need to know other than this data? We have P, we have Q, we have D, right? What else do you need? Just tell me on the chat. Yeah, attrition rate, dropout. Yeah, the other name is attrition rate for dropout. Okay, very good, very good. So you are following me. Thank you so much. So you need the attrition rate or dropout. Okay, good. So I'm giving you that attrition rate is 20%. So you plug in the numbers, you come up with 384 sample size that you need to study. But if you have 20% dropout, 20% of this is 77. Do you subtract from this number or you add that number? Right on the chat box. Do you subtract or add? 77. Add. Good, 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 good. I'm so happy. I'm so happy. Okay, thank you so much. So you add that 77 to the required sample. So your total sample would be 481. So since this is another thing I just want to point out, that you need 481, but if you do 480, is it bad? It's okay. If you do 490, is it better? Yes, I should say better. But definitely you need 481 samples, but you can do more, but not less, not less. Okay. Okay. Now, okay. Now I have another things to show you. Okay. Let me see what I said. So what if your dropout rate is more? I said 20% dropout, but if you see your dropout rate, actually it is more than 20%. Once you start your study, you see more people are dropped out. What you will do? Tell me in the chat box. Tell me. Waiting. One answer. Anybody? Add more sample. Add more sample. That's the answer. So what I or as a researcher, what we should do, in that case, you do an interim analysis. Interim analysis means your study is not done. You are continuing the study. So you will revise your sample size based on the new dropout rate. If it is 30%, you calculate 30% of 384, not 30% of this total original sample size that you required. You calculate 30% of that and then add that number to the total. That would be your new sample size. So you do an interim analysis. Okay, good. Thank you. You increase it. All right. In Malaysia, this is my last one. The prevalence of breastfeeding. I actually looked for it and I found prevalence of breastfeeding among, I wanted to do among employed mothers, those who are working mothers. Okay, so their number, prevalence of breastfeeding is very high, around 95%. However, when we talk about exclusive breastfeeding, okay, this varies from 15% to 25%. Okay, this is the data I got from some literature. So this is a real data, okay? And let us do a study on exclusive breastfeeding. Exclusive breastfeeding rate varies from 15 to 25% among employed mothers. Okay, let's do this. Okay, so I got a range, this to this. What I did, I took an average. You can do both. Actually, you can do with using this number and this number, but if you use this number, your breastfeeding rate will, sample size would be less. So it's better to do an average. Okay. So that's what I did. 20% I used as the average of people who are breastfeeding, exclusive breastfeeding among employed mothers. So we want to conduct a study to improve the rate of breastfeeding, exclusive breastfeeding in 1 year time frame after educational intervention. This is your study. And your hypothesis, the breastfeeding rate will increase after educational interventions. Good. So in our study, we have a very high attrition rate. That's I'm thinking that the attrition rate, I was actually thinking about it, that because we are talking about employed mothers, okay, the attrition rate, those who will be dropping out may be more than normal because they are working. Okay, may not everybody will be participating in your research because they're time constrained. Okay, so I took 30% as the attrition rate or the dropout. I'm using two words. One is attrition, one is dropout. It's the same thing. Okay, so our type 1 error, alpha is 0.25, confidence is 95%, precision rate, I want to use 5%. It's generally we use 5%, but you can do, if you want to increase your sample size, you can go for 3%, 4%, no problem. It's more precision. But if you go for higher number of precision, you are going away from the real value. Okay? General rule of thumb is 5%. Okay, so let me get the P is 0.2 because 20%, Q is 0.8, G is 1.96, dropout, D is 5%, 0.05, dropout 30%. Got all the data, plug in, we got N 246. So if you want to really do the study, you need to increase by 30% because 30% may be dropped out. 30% of this number is 74. You do not subtract, you add that, and you need 320. That is your good number to do the study. Now I stop sharing this and I go back to you. And now, is everybody with me? Did anybody drop out from the group after my lecture? Anybody dropped out? Okay, hope no. So I see a lot of thumbs up. I like it so much. Thank you so much. So now you tell me, did you have those who are new? Okay, those who are new, those who learned this first time, did you have a good sense how to calculate sample size? At least for cross-sectional study. Najib, yes, thank you. And I see Nadia, thumbs up. Muhammad Arif, thumbs up. Marini, thumbs up.
Rob, you are giving a very good, lecture today. Thank you very much. It is so impressive because I think that it will be help a lot of people.
Thank you.
Yeah.
Thank you so much. I appreciate your good comment, but I also okay if somebody really didn't learn anything. I can answer your questions if you have any questions. Okay, there is a question here. When do you inflate the sample number because sometimes people inflate twice than the calculated sample. No, that is not really good to inflate your sample size 2 times. What I said at the beginning, if you have two groups instead of one group, then you multiply by 2. But you need 300 people and you are starting with 600 people. You know what? People will say this is an improper study design. Why? Because you are increasing cost, unnecessary cost of your research. Every number is important, but every number means there's a cost involved. There is some dollar involved. So if you need 300, it's not wise to do 600 people because you are increasing the sample size unnecessarily. You are really not gaining. You are really not gaining mass if you double your sample size. Okay, so it's not a good study design. I see. What about a cross-sectional and repeated measure study? Repeated measure study is another important thing, because when you do repeated measure, you may lose somebody in second time you study. Okay, so you have to take care of that, because in the same cross section of people you can do multiple studies, right? You can do one time, you can do multiple times. So in repeated, sometime, if you have a good rapport with the population, you will not lose many people. But if you have not good rapport, so build up rapport, relationship before you do a study. That's important. Okay. But in repeated analysis, repeated measure study, you may lose many people. That you have to add to the total. I'm checking if there is any more. The final.
I have one question. Can I?
Well, please go ahead.
Okay, regarding this cross-sectional study, if we have two objectives, where objective number one is to determine proportion of a disease in a population, and then the second objective is to determine another proportion of another disease among those that having first objective disease. Do we have to calculate another sample size, or we use sample from objective one?
Najib, this is an excellent question, because for each of the major variables, remember, in your study, you may have some major variables and some minor variables, okay? We don't care about the minor variables because those are not important, a very important part in your study. But if you have two major components that you are studying, okay? Let's say in my study that I mentioned about the iron study in children, morbidity, we calculated their pneumonia, diarrhea, whooping cough, measles, dysentery, those, and septicemia, or if anybody died of any accident or anything, drowning, for example, for children, we that also had that. So anything that your major component, major variable, drowning is not my variable that I thought that it will happen. So we didn't calculate sample size for drowning. So that, because that is an accident, we didn't expect that. But we had to calculate sample size for diarrhea, pneumonia, measles, and other major things. Now, because their prevalence is not the same, then you may come up with a larger sample size for one factor, smaller sample size for another factor. What you should do, come up with the largest sample size to care of all the variables. So for some variable, if you need, let's say 100, for another variable you calculate and you got 200, you'll use 200 as your required sample size to cover everything. Thank you, Najib. That's excellent. That's an excellent question. Any more? We already had 1 hour. If you want to stay, I'm okay. But if you have questions, please let me know. Okay.
Hi, Prof.
Yeah.
One more
please.
question, Prof.
Mhm.
Regarding the precision, I noticed that people use variety of precision. How actually they decide the precision value?
Yeah. Precision, as I said, it ranges, it varies, but if you do not really have enough information, how much precision you should do, general rule of thumb, 5%. General rule of thumb, 5% precision. You should be okay if you use 5%. If you do 4%, it's better design. But you don't have to go for 2% or 3%. You don't really. But I will not do at 10% because the small sample size will not really be realistic for a study with a larger or wider range from the real value. Okay, Najib?
Okay, Prof. I have one example. Let's say the estimated proportion is 5%. Is it okay that
Estimated
we use
proportion.
precision
Okay.
5%
Okay.
as well?
Okay. So estimated proportion means your proportion for the variable of interest is 5%, that you say?
Yes.
Okay.
Yes.
So if you're, so you take your P is 0.05, right? 0.05 times 1 minus P is 1 minus P is your Q. So that would be 0.95. 5% is your variable of interest, or the proportion of the people that you are going to study is only 5%. So 5 means 0.05 is your P. And so Q is 1 minus 5%, which is 0.95. Okay. And then I'm just trying to calculate very quickly. 1.96 is your G, that square it, okay? So what is your D? I said take 5% or 4%. Najib, what do you want to do? Precision.
I want to make it 5. The
Okay.
larger the precision, smaller the sample size.
Okay, good. So 5%, so that's square. So now I'm calculating with my calculator here. So so 0.05, which is the denominator, I square it, I keep it on my, and that's how I do it. I calculate my denominator first, keep it on memory. So 1.96 square times 0.05, that's your P, times 0.95 equals this, divide by your denominator. Oh, I get only 73 people. I may be wrong in my calculation, but what I did quickly is 73 people you will need to study. Then you have to add the dropout. If it is 20%, 20% of 73, and then add to the total. Okay, Najib?
Okay, Prof.
So if you want to do any research, you will give me, you will calculate. Now you can calculate that. But if you want to make it sure, this is the number you should start with. You can send me the information. I can calculate it for you. Not only for cross-sectional study, we'll do another session for other type of study. Then I will expect that some of you really work with me about study design, and I'm ready to help you. Professor Hamid Jan is back here or not? Okay. Okay. So any concluding statement? Professor Hamid Jan?
Just want to have everyone here. Have you answered Dr. Faisal?
You are breaking. We don't hear you properly. Sorry. Don't hear it properly.
You hear me now?
Yeah.
Just want to check whether you have answered everyone's question in the chat box.
Anybody has any burning questions?
I think in the chat box there were some people asking questions. Did you manage to answer all, Prof?
I don't know. I have not seen everything, but if
Oh,
there's
there are
any more
some.
questions, please tell me.
Yeah, I think it's best.
Another thing I should tell you that sometimes there are some published handbooks, especially the next time when I talk about other sample size, this that I told you, this is easy one, but there are some complicated calculations. Some people use some reference books and just use a number. This is my power, this is my confidence. So get the number from a table. Okay, that's okay, because people have made the tables available for you to calculate it. But I want to see in your project, if I am a reviewer, I want to see how you calculated, what formula you have used. If you say, I got it from a reference table, no, I will not buy it. You have to show me. And that happened one time, I remember that one professor, he's a full professor. He was telling me, we'll do a research with 32, I'm just making a number, 32 samples. I remember, so I asked him, why you use 32? His answer was from the table. And another thing he said, this is the number in previous studies people used. For same study, they used 32 or 30, I used 32. I said, I'm sorry, I cannot approve your project. I want to see if somebody has done wrong in the past, you want to repeat the same mistake in your research? No. Okay. So I want to see how you calculated your sample size. Okay. So
Okay.
that's me. Okay.
Excellent advice. I think it's very important advice because people always go away with the table. I think your message is very clear. I think at the end of the day, I think the viewer wants to see the way it was, calculated. It's very important. I must say to you that today we had a good number of 130 participants.
Wow, I like it.
Wow. Wow, it's a record. It seems
Please,
that people are very interested in the topic.
I want to see increased sample size in my lecture.
We'll try. Hopefully,
Okay.
this will come back in the second session,
Yeah,
and we
please.
will have more people in the second session. We will announce the date once I have communicated with Prof. Amal. But I think, Alhamdulillah, we have a very good session. People learn a lot. I will definitely revisit the video in the PPSK YouTube channel. And for those who want to do revision, you can look back at the videos that we have uploaded. Please don't forget to mark the attendance for CPD. It is in the chat box. And I look forward meeting everyone online again. Okay, Prof.
Thank you so much. Doing so hard work for me and getting the information out to people. I appreciate everybody who joined today. Hope it will be useful to you. Bye-bye.
Okay, bye-bye. Bye, everyone. Assalamualaikum.
Walaikum salam. You have a very good day. I'm leaving now. Thank you.